Hello, everyone. I hope everybody is healthy and fine. And in this lecture, we just want to discuss the properties of sinusoidal functions and the formulas that are involved. And we want to learn how to find the period or amplitude or max value, mean value, and the equation of axis of the curve and all that, given the equation of a sinusoidal function. A sinusoidal function that has undergone transformations, generally speaking, can be either in the form of a sine function or a cosine function, and this is like the general formula. Um, let's start with x. What is x to begin with? X is actually the independent variable. So I put here independent variable, just like in parabolas y equals x squared, x was the independent variable. And the values of the independent variables are the input values for the function, and actually we have no restriction for that. And that means that the domain of sinusoidal function is the set of real numbers. So that is the domain. So x is the independent variable, and the domain is the set of real numbers, which means that you can select any x value you want. Instead, y is called the dependent variable, and the values of y are determining the range of the function. So if you want to find the range, I'm going to talk about the range later, but the values of y that are real numbers with some restriction, which I'm going to explain, that is going to be the range of the function. Then the other letters, we start with A, perhaps. A represents the amplitude, but we know that A sometimes is negative due to the existence of a reflection in the x-axis. So maybe the function is -2 sine of something, or -3 sine of something. So if A is -3, we cannot say amplitude is -3, because amplitude is always positive. It's a distance between the maximum point or the minimum point and the axis of the curve. So that's why we should say it is absolute value of A. So whatever A is, blindly, just don't say the amplitude is -3. It is absolute value of -3, which is +3. So that's for the amplitude. Then the role of K, we know that K generates a horizontal shrink or horizontal stretch. Okay, that's the role of K in terms of transformation. And it gives us the formula for the period, which is 2 pi over K. Okay, 2 pi over K. And K is that number that is given in the equation. It also represents the number of cycles from 0 to 2 pi. If K is a negative number, which is a possibility because we may have reflection in the y-axis, again, we don't say period is negative. Therefore, to be very accurate, very precise, we should actually say 2 pi over absolute value of K, so that we don't end up with a negative answer. The role of D is actually the phase shift. So phase shift is equal to D. That's the size of the phase shift. That's the magnitude. But depending on D being positive or being negative, we have this horizontal shift to the right or to the left. So this is to the right, and this is to the left. So depending on the value of D being positive or negative, the horizontal shift happens to the right or to the left. But the size or the magnitude or the amount of shift, horizontal shift, is determined by the value of D. And then we have the value of C, which identifies the vertical displacement. So vertical displacement, or you can say vertical shift or translation. all of these mathematical terminologies are valid. You can use them. And to find this C, okay, amount of vertical displacement, um, it is actually because this axis of the curve is always between the max mean, right? So what you're going to do to find the middle value or mid value between the max and mean, you just add them up divided by 2, or find the average of the max and mean basically. So if you take the max value and the mean value and find the average by adding them up divided by 2, that gives you the value of C. And if C was positive, it's going to be up. And if C was negative, it's going to be vertical shift down, of course. Okay? So that is the amount of vertical shift, because max mean values can be negative or positive. So when you're finding the average of two numbers, you might end up with a negative answer. And that, if that is negative, it means C is negative, and that means that the amount of vertical shift was C units down and not up in that case. And how is this going to help us to find the equation of the axis of the curve? Well, it's very easy. Y equals C is the equation of the axis of the curve. Okay, so Y equals C. Any other formulas I can share with you? With the amplitude, you know the amplitude, what the amplitude is. The thing is that between the max value and mean value, there's two amplitudes basically. So that means that if we subtract the mean value from the max value, take that distance between max and mean, I mean capital M minus lowercase m, and cut it in half, that will be the amplitude. So basically we can say max minus mean divided by 2, that will be the formula for the amplitude of a sinusoidal function. If the max value is 10, mean value is 6, 10 minus 6 would be 4. That's the distance between the max and mean. And if you cut the 4 in half, it's going to be 2. So 2 units above the axis of the curve, 2 units below the axis of the curve. So the amplitude will be 2 units. The lowercase m that I write, that is actually the minimum value. Okay, so minimum value, I show it with lowercase m, minimum value of y, and the maximum value of y, so max value is denoted by capital M. So this capital M, lowercase m, they stand for max value, mean value of the sinusoidal function. And to find the mean value, you can take the negative of the amplitude, which was absolute value of A. But because there's sometimes some vertical shift involved, so we're going to add this with C as well, and we're going to say this is the formula for the minimum value of a function. So if you know the values of A and C, you want to find the minimum value, this is the formula you can use. It's going to be C minus absolute value of A. In case of max value, you can say max value of the function is magnitude absolute value of A plus C, of course. So that will be maximum value of the sinusoidal function. Is there any formulas I missed here? I doubt it. Everything is explained. Oh yes, the range. So when we say max value is found by this formula, mean value by this formula, that means that the range of the function is always going to be between the max value and mean value, right? So I should say here that y is between, or trapped in between, max value, which is C plus absolute value of A, and C minus absolute value of A. So that becomes the range of the function, which shows all the y values between the max and mean values for this sinusoidal function. So domain explained, range explained in terms of HADC values. All the formulas are there. Equation of axis of the curve, phase shift. How do you find the equation of axis of the curve? It's going to be y equals c, but c itself is max plus mean divided by 2. And formula for the period, 2 pi over k, amplitude, and range, max value, mean value. So if in a question they give you the maximum mean value, you can easily find the amplitude. You can easily find C, which is the equation of axis, the curve y equals C, and from there one by one you can solve all parts of the puzzle. So these formulas you need to know. I hope you will know them. And even for graphing, actually, for graphing sinusoidal functions, step one is identifying all the properties of a sinusoidal function. And if you know these formulas, you will easily do the step one of graphing procedure in like few seconds. Okay, I hope you are going to find these formulas useful, and I hope you did take notes. Thank you for your attention.